Imagine that we are playing a game and I ask you to write the number 8. Excuse me. We're playing the game and I ask you to write the number 8. But it's two rules. It's two rules. The first rule is that you cannot represent 8 with this symbol and this picture that I just put on in the box. You can't use this number to represent 8. That's the first rule. And the second rule is you cannot use any addition symbols, no minus symbols, no multiplication symbols, and also no division. Excuse me, no division symbols. How would you try to win this game? How would you try to figure this out? You have to represent the number 8, but you can't use the symbol in the box. Excuse me. And you also cannot use any addition, subtraction, multiplication, or division symbols. How would you go about figuring this out? If somebody were to ask me that question, what I would naturally move towards is two things. The first thing that I would try to do is tally marks. So I would do something like this. I would try something like that. And if not that, then I would do something like this. I would have to make up another picture or symbol. Symbol fade. I would make something up like this. And just say like, that's the number 8. Now, ain't no telling if that's going to win me the game or not, but it's interesting to think about. Let's try this game one more time with a different number. Let's say we have to represent a different number. We don't have to represent 8. Or I don't ask you to represent the number 8. Let's say I ask you to represent this number right here. You have to represent this number, but it's two rules. You can't use the picture that I use. You can't use the numbers that I use in that box. And you also cannot use any addition, subtraction, multiplication, or division. How would you represent this number? And it's pretty much the same. If somebody was to ask me this question, I would think of two main ways that I would try to figure this out. Again, I would try to tally this thing up, which would be torture for real. But I would try to write these tally marks out. And again, secondly, I would try to figure out some new way to show, some new type of picture to show 517, Now, for us, this is a game that we're playing right now. We you know what I'm saying? We just playing. We just trying to, we just having a little bit of fun, you know what I'm saying? Trying to figure this out. But for our human ancestors 10,000, 20,000, 50,000, 100,000 years ago, this was a real situation. Before we invented this notation and these numerals, think about how would people have represented large numbers like this. And that's just something to kind of shed light on why we have adopted this place value system and kind of the usefulness of it. So let's go back to this number 517 one time. Now let's fast forward to 2025. we are using a place value system to represent all numbers that we want to think about. The reason that we use the place value system, I'll explain a little bit later. But what you need to know about this place value system is a few things, a couple of things. It's a couple of things that you need to pay attention to. You need to pay attention to the digit. And the digits is everything from 0 to 9. That's the first thing you got to pay attention to in the place value system. And the second thing that you really got to pay attention to is the location of the digit. So for example, is it first? Is it second? Is it last? Is it the furthest to the right? Is it the furthest to the left? These are the two things that you really gonna want to pay attention to in our place value system, because it's information encoded in these two things. So let's go back to 517. Look at this number 517, for example. So again, in 2025, we do not use tally marks and symbols anymore to represent really large numbers, because using tally marks and writing pictures takes up a lot of time and takes up a lot of space. It's really inefficient. So this is why we don't use tally marks and symbols or pictures as much, or really at all, like our ancestors did, again, 10,000, 20,000, 50,000 years ago. Using tally marks and pictures, it takes up a lot of time. It's real time consuming, and it takes up a lot of space. You need a bunch of paper after a while to keep up with all of this. The solution to both of these problems is the place value system. The place value system says that every number or every digit and the location that that digit is in will tell you information about the whole number. So for example, we have this thing called the ones place. And the ones place has a digit assigned to it. And that digit is going to be from 0 to 9. Let me draw it the other way. And in the ones place, you can only put a symbol or a picture from 0 to 9. You can use 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. And in the ones place, there's two rules that, a digit is assigned to the ones place, and whatever digit is in that ones place represents however many ones that it is, however many groups of one. Excuse me. In the ones place, whatever digit is assigned there lets you know how many groups of one. For this one, we got 7 groups of one, so we can tally that real easily. 4, 5, 6, 7. Cool. You know what I'm saying? That's nothing. Now, if we have something greater than 9, which there are an infinite amount of numbers bigger than 9, how do we go about representing them? Well, for any number greater than 9, we make a new place. We make a new place for that value, for those values greater than 9. So, and the same rule applies as in the ones place. So we have a place for numbers that are bigger than 9. So we assign a digit 0 through 9 in that place. Excuse me. And so whatever digit is assigned to that place lets you know how many groups of 10. Now, it's not just, it's not like a number bigger than 9, like 12. Each location, each place has a set value. There's a ones place, there's a tens place, there's a 100s place, there's a 1000s place, and so on. There's not a 12 place. There's not an 11th place. We'll talk about that in another video. Groups of 10 were chosen, or powers of 10 were chosen because it was just efficient. We'll just say that for right now. But in the tens place, the same rules apply as in the ones place. A number or a digit is assigned to that place, and that number lets you know how many groups of 10 that you got. So just following along with this type of notation and reading, of course, left to right, our ancestors, again, 10,000, 20,000, 50,000 years ago, they were able to do what with this? They were able to do what? First of all, they were able to write large nums. They were able to write large numbers, which is really important. Whether or not you understand this, our ancestors were living very complex lives, and they dealt with very large numbers all of the time. They were harvesting crops. If you were a ruler or a king or queen, you had to keep track of your subjects, 70,000 people. You making clothing, making cookware, and things of that nature. You're dealing with really large numbers. And so when you write these numbers, you need it to not take up a whole bunch of time. You cannot spend all day writing 70,000 tally marks or counting 70,000 tally marks. And also, you don't want it to take up a whole bunch of space. We don't have all the paper in the world. We can't waste paper trying to write the number 517. So what this place value system allowed, again, our very ancient ancestors to do was to write large numbers without taking up a lot of time and a lot of space. Let's move on to the final place for this decimal system. Decimal means just every place is a factor, a multiple of 10. So we got our ones place, it's 7 in the ones place. So this is 7 groups of 1. Groups of 1. And for this tens place, I'm gonna do that in a different color. We got 1 group of 10. Right, and now finally we have the 100s place, and the same rules apply for this 100s place. We assign a digit 0 through 9 to this 100s place. We assign the digit to this place. And what this tells us is not the number 5. This is not 5 ones, but this, because of the location of the 5, we know that this is 5 groups of 100.